Welcome back, everybody. And today we're going to look at adding and subtracting rational expressions. So this is going to be a lot like adding and subtracting fractions, which you learned so long ago when you were in middle school. So as an example, let's say I wanted to add 2/5 plus 1/5. So just like with fractions, when your denominator is the same, you're just going to keep the denominator and add the numerators. And then similarly for subtraction, if your denominators are the same, you keep it and then just work with the numerators. And then if you have a different denominator, so let's say 2/5 plus 1/4 instead, you have to get a common denominator by multiplying by another number. In this case, it's just going to be the opposite denominator. And this is exactly what you're going to do when you have a rational expression. So I have 8/20 plus 5/20, which equals 13/20. So kind of keep this process in mind as we go through our rational expressions because it's the exact same process. So let's first try some with a common denominator. So to add, just combine like terms in the denominator and then combine like terms in the numerator, and keep your denominator. So my denominator is still going to be x plus 1. And then, so in the numerator, I'm combining like terms. So let me first just write it out. So there's the first numerator and then the second numerator there. All right, so now I'm going to combine like terms. So x squared, there's no other x squared, so I'm just going to write it down. And then negative 3x plus x is negative 2x. And negative 2 plus 4 is positive 2. And so there is my sum. And I've combined them successfully into one single ratio. All right, so subtraction, pretty similar. To subtract, first distribute the negative sign through the second numerator. So we're going to take this guy and distribute it through all the terms, and then combine like terms just like we did here. So what I actually would like you to do is this. So I'm going to copy that. I want you to kind of get used to taking this minus sign and turning it into plus and negative. And I think that may help you to not forget to distribute it first. So it's just a suggestion. All right, so there's my first numerator. Notice it didn't change, just leave it alone. And then I need to distribute my negative or my negative 1 if you want to make that a negative 1. So minus 2x squared minus 1x plus 4 all over x plus 2. So notice all I've done so far is every sign on the second numerator flipped because I am subtracting. So when I distribute that negative 1 or that negative sign, if you want to think of it that way, my signs just flip. So now I can combine like terms. So x squared minus 2x squared is just negative 1x squared. 5x minus x is 4x. And negative 1 plus 4 is 3. And then over x plus 2. And there's my difference. All right, I want you to think for a second. What do you think is the most common mistake people would make on this step right here? And I'm going to ask you about it on Ed Puzzle right about now. So in class, we'll go over these two. I'm going to have it probably as your warm-up to go ahead and do those. So leave them alone for now, and let's go inside. Now, inside, we're going to be looking at what do you do if your denominators are not the same. So remember, when you have numbers, you have to find a common denominator first, and that's what we're going to do here as well. So taking the first one, it's an addition problem. I need a common denominator. So what I'm going to do, find a common denominator by multiplying the numerator and denominator by the same value. And in general, what you want to do is just take the opposite denominator. It's not always going to be the simplest way to do it necessarily, but it will at least work. So that is my suggestion. And actually, you may want to put parentheses around them. Okay, so here's my first fraction. I'm going to change it so they both have the same denominator. So I have 3 times x minus 8. So 3 times x is 3x. 3 times negative 8 is negative 24. And then my denominator, make that look a little neater. You could do the box method on this to get it simplified, but we'll do that a little later. I'm not going to do it right now. So for right now, just leave that denominator like this, x plus 7 times x minus 8. And just for now, just kind of leave it unsimplified. So my first fraction, which was 3 over x plus 7, became this. So now we need to change the second fraction to also have the same denominator. So notice this time I'm going to be multiplying by the x plus 7. So I have 4 over x minus 8 times x plus 7 over x plus 7, which equals 4 times x is 4x, and 4 times 7 is 28. And then over, and you can flip the order so it matches if you want. It doesn't make a difference what order you multiply in, so it's the same denominator either way. All right, cool. So I have my two fractions, and I made equivalent fractions that have the same denominator. So my values haven't changed. They just look different so that the denominators are equal. Now that you've done that, you basically have this problem all over again. All you do is combine like terms in the numerator and keep your denominator. So let me rewrite it here. So I have 3x minus 24 over x plus 7 times x minus 8 plus 4x plus 28 over the same denominator. So then I just want to combine my like terms. So 3x plus 4x is 7x. Negative 24 plus 28 is 4 over x plus 7 times x minus 8. Yeah, let's go ahead and do box method and get and simplify the denominator now. So x plus 7, x minus 8. I have x squared. 7 times x is 7x. X times negative 8 is negative 8x. And 7 times negative 8 is negative 56. So my new denominator is x squared minus 1x minus 56. And then the last step is to simplify if you can. Usually you're just going to have a common factor on all your terms. So you want to look at all of your terms and see, is there something I can divide out of all of those terms? And in this case, there's not. Like even looking at 7 and 4, there's nothing that you can take out of both of those. So in this case, we're done. So just write the sum over again, and you're done. Yay! Right, subtraction. We're going to be doing the same thing. So kind of combining this with the other subtraction problem. We need a common denominator first, and then we're going to distribute that negative sign and combine like terms in the numerator. So step 1, to subtract, find a common denominator. So actually I could simplify this, but I'm not, so I can show you the simplify step at the end. So just if you're looking at this and going, but Miss P, they both have a 4 in them, and that's divisible by 2. Just hold off on that. So let me get my common denominator first. So I'm going to take my first fraction and just multiply by the other denominator, which is a 2. Let me put parentheses there. So 3 times 2 is 6. 4x squared times 2, that looks funny, is 8x squared. And 4x times 2 is 8x. So there is my first fraction just in an equivalent form, but so that I can get the same denominator. And then take 7 over 2 and multiply it by this, the other denominator. And we get, so 7 times 4x squared is 28x squared. 7 times 4x is 28x. And then my denominator, whoops, forgot that parentheses. My denominator will be the same as up here, which was the entire point of doing this, if you'll recall. So I've got my equivalent fractions all ready to go, all ready to be added together. And you may be looking at this again and going, well, these are all even numbers. Can't I simplify this? Yes, you can. We'll get there. If you wanted to, you could simplify now, but again, I'm just going to wait till this step to show you in this example. Okay, so distribute the negative sign through the second numerator, then combine like terms. So let me first rewrite what we've got. I'm taking 6 over 8x squared plus 8x minus 28x squared plus 28x over the same denominator. And then, so let's rewrite that. So let's go plus a negative. Okay, because remember, subtraction and plus a negative are equivalent. They're the same thing. So I have 6, and then I want to combine like terms in my numerator. So 6 minus 28x squared minus 28x over, and the denominators will stay the same. So that equals that, and then equals, all right, so actually there's no like terms here, because x squared, x, and just a number, so yay, we're actually done with that step. So you may want to put it in order though. Usually we go in order from greatest to least exponent, so x squared, then x, then the 6. Okay. Now it says simplify if you can. So let me rewrite this, because you may be looking at this and realizing that all of these numbers are actually divisible by 2. So we can factor out a 2 from everything and cancel it. So if I divide this by 2, I get negative 14, 3, 4, and 4. So just simplifying a little bit so it's not any bigger than it needs to be. So since all of those are divisible by 2, and then I have no more common factors, then I have my answer. There's my difference.